So students, now let's start activity 2.2, principal value of an inverse trigonometric function. So our objective for this activity is to explore the principal value of the function sin inverse x using a unit circle. So now let's see the method of construction for the given activity. First, take a cardboard of dimension 40 cm by 40 cm. Take a graph paper cut it into a square shape and paste it on the cardboard. Draw a unit circle with center O. Step 4. Draw two perpendicular lines passing through the center of the circle. X dash OX and YO Y dash as coordinate axes. Draw two perpendicular lines passing through the center of the circle, that is X dash OX and YO Y dash as our coordinate axes. So step 5. Mark the points A, B, C and D respectively where the circle cuts x-axis and y-axis. Mark the points A, B, C and D respectively where the circle cuts x-axis and y-axis. So, the circle cuts x-axis at point A and the coordinates of this point is, as this is a unit circle of radius 1, so the coordinate is 1, 0. Here, this is point B where the circle cuts positive y-axis and the coordinates are 0, 1. This is point C and the coordinates are -1, 0. And this is point D. The coordinates are 0, -1. Now step 6. Fix the two rails on the opposite side of the cardboard. Which are parallel to y-axis. Now, fix the two rails on the opposite side of the cardboard which are parallel to y-axis. Now fix a wire between the two rails. Such that the wire can be moved parallel to x-axis. Fix a wire between the two rails such that the wire can be moved parallel to x-axis. Now step 7. Take a needle. Take a needle of unit length. Fix one end of the needle at the center of the circle and the other end to move freely. Along the circle. Take a needle of unit length, fix one end of the needle at the center of the circle and the other end to move freely along the circle. So this is the wire that is tied between the two rails. These are the two rails that are parallel to y-axis and the wire becomes parallel to the x-axis. Now take a needle, tie one end to the center of the circle and other end to move freely over the circle. So this is the needle that has been tied at the one end to the center of the circle and other end is free to move over the circle. Let's name this point as P1. In the similar way, this needle can be moved freely over the circle and the one end remains fixed at the center O. So students, now let's move on to our demonstration for the given activity. First, keep the needle at an arbitrary angle, say x1, with the positive direction of x-axis. Here, measure of angle in the radian is equal to the length of the intercepted arc of the unit circle. Now, in step 2, slide the wire between the rails parallel to x-axis such that the wire meets free end of the needle. This, let's say, the point to be as point P1. So we slide the wire between the rails to meet the needle at the point P1. Denote the y coordinate of point P1 as y1, where y1 is the perpendicular distance of the wire from x-axis of the circle giving y1 equals to sin x1. Step 4. Rotate the needle further anti-clockwise and keep it at an angle pi minus x1. Find the value of y coordinate of the intersecting point P2 value of y coordinate for the points P1 and P2 are same for different values of angles. That is, y1 equals to sin x1 and y1 equals to sin pi minus x1. This shows that sine function is not one-to-one for the angles considered in first and second quadrant. So the value of y coordinate for the points P1 and P2 are same for different values of angles. Y1 equals to sin x1 and y1 is also equal to sin pi minus x1. This shows that sine function is not one-to-one for the angles considered in first and second quadrant. Now, in step 5, keep the needle at the point, keep the needle at angle minus x1 and minus pi plus x1. That is minus x1 plus minus pi plus x1. By sliding down the wire parallel to x-axis, show that the y coordinate for the points P3 and P4 are same, and thus the sine function is not considered one-to-one for the points in third and fourth quadrant. Keep the needle at angle minus x1 and minus pi plus x1 respectively by sliding down the wire parallel to x-axis. Shows that the y coordinate for the points P3 and P4 are same, and thus the sine function is not one-to-one for the points in third and fourth quadrant. Now the point 6. However, the y coordinate for the points P3 and P1 are different. That is, for P3 and P1 y coordinate is different. Move the needle in anti-clockwise direction. Starting from pi by 2 to minus pi by 2, and look at the behavior of the y coordinate of the points P5, P6, P7 and P8. by sliding the wire parallel to x-axis. So the y-coordinate of the points P5, P6, P7 and P8 are different. Hence, the sine function is 1 to 1 in the domain pi by 2 minus pi by 2 to pi by 2, and its range lies between -1 and 1. Now step 7. Keep the needle at any arbitrary angle Keep the needle at any arbitrary angle say 0, lying in the interval minus pi by 2, lying in the interval minus pi by 2 and pi by 2, and denote the y-coordinate of the intersecting point P9 as y. Keep the needle at any arbitrary angle say theta lying in the interval minus pi by 2, and denote the y-coordinate of the intersecting point P9 as y. Then y equals to sin theta and theta equals to arc sin inverse y. So theta equals to arc sin inverse y as the sine function is 1 1 and onto in the domain range minus 1 to 1. So its inverse arc sine function exists. So keep the needle at any arbitrary angle, say theta, lying in the interval minus pi by 2, pi by 2, and denote the y coordinate of the intersecting point P9 as y. Then y equals to sine theta and theta is equal to arc sine inverse y, as the sine function is 1 1 and onto in the domain. So the range minus 1 to minus 1. So its inverse arc sine function exists. The domain of arc sine function is minus 1 1 and range is minus pi by 2, pi by 2. This range called the principal value of sine inverse function. Or arc sine function. So the domain of arc sine function is minus 1, 1 and range is minus pi by 2, pi by 2. This range is called the principal value of sine inverse function or arc sine function. So students, now let's move on to observation for the given activity. So our first observation is sine function is non-negative in the first and second quadrant. For third and fourth quadrant, sine function is non-positive. Theta is equal to arc sine y implies y equals to sine theta, where theta is greater than or equals to minus pi by 2 and less than or equals to pi by 2. That is, theta is in between minus pi by 2 and pi by 2. So theta equals to arc. So theta is equal to arc sine inverse y, which implies y equals to sine theta, where theta is in between minus pi by 2 and pi by 2. So our fourth observation is the other domains of sine function. So the other domains of sine functions on which it is 1 1 and onto provides pi by 2, 3 pi by 2 for arc sine function. So the other domains of sine function on which it is 1, 1 and on 2 provides pi by 2, 3 pi by 2 for arc sine function.